Now let us see children, lines and angles, class 9, exercise 4.4. So in the given triangle, find out angle x, angle z. Given triangles, find out angle x and angle z. So first triangle, here we have to find x degree. So in the given figure, by observing this, we can write x degree is equal to 50 degree plus 60 degree. How? Yes, by using this condition, exterior angle is equal to sum of the opposite interior angles. So here x degree is the exterior angle of this triangle and 50 and 60 are the interior angles which are opposite to this exterior angle. So we know this condition as exterior angle condition. Now by that we can say 50 plus 60, 110 degrees. So in given figure, one more we have z degree here. Z degree is equal to, we have 60 plus 70. So exterior angle is equal to the sum of the opposite interior angles, that is z degree is equal to 130. Same type of sum. Now let us see this figure. In the given figure, AS is parallel to BT and angle 4 is equal to angle 5. See children carefully. Observe the figure carefully. Here the line AS is parallel to BT and angle 4 equal to angle 5 and SB bisects angle AST. That means it divides this angle into two equal parts. Okay. That means angle bisector. Here SB is the angle bisector of angle AST. It divides this angle into two equal parts, that is angle 2 is equal to angle 3, we can say. Now by this given, we have to find measure of angle 1. We have to measure this angle, we have to find this angle. Now in the given figure, AS is parallel to BT, angle 4 is equal to angle 5 and moreover SB bisect angle AST. So by the problem we can write angle 2 is equal to angle 3. Say equation 1. Now for the lines A is parallel to BT, angle 2 is equal to angle 5. Why? Actually these two are, angle 2 and angle 5 are alternate interior angles. So as we know, whenever two lines are parallel and then we have the one pair, so which are alternate interior angles, those two are equal. So as we know that one. So now in triangle BST, observe this triangle BST, angle 3 is equal to angle 5 is equal to angle 4. How can we say like this? So simply seeing these relations, angle 2 equal to angle 3, angle 2 equal to angle 5, both are equated to same angle, so that's why angle 3 equal to angle 5. But again angle 5 is equal to angle 4, so angle 3 is equal to angle 5 is equal to angle 5 by seeing the relations. Hence we can say BST is a equilateral triangle. Okay, so how can we say BST is equilateral triangle? If the three angles are equal in a triangle, then such triangle is equilateral triangle, as we know that one. So that's why here triangle BST is an equilateral triangle and each angle is ultimately equal to 60 degrees. So angle 2 is equal to angle 3, angle 3 equal to angle 4 equal to angle 5 equal to 60 degrees, but here we have angle 2 equal to angle 3, so each is equal to 60 from equation 1. Now observe this, angle 1 plus angle 2 plus angle 3 is 180 degrees. Why? Because here OT is a straight line. On this straight line we have three angles, 1, 2, 3. So that is these three angles lies on a same line RT. So that's why we can write angle 1 plus angle 2 plus angle 3 180 degrees. Now substitute angle 2 and angle 3 60 degrees. Angle 1 plus 60 equal to 180. So angle 1 plus 120 equal to 180. Then angle 1 is equal to 180 minus 120 is equal to 60 degrees. Okay, so like this we can measure angle 1, or I can find out the angle 1 very easily. So but it is very important. Here we applied alternate interior angles and equilateral angle definition and the angles on a straight line. Okay, so be careful while doing these sums. Now another interesting sum. In the given figure, AB is parallel to CD. Once again, see the question. So first we have to understand the sum clearly. Okay, if you understand clearly the given geometrical sums, you can easily solve. So here AB is parallel to CD, and also given BC is parallel to DE. Then find the values of x and y. Okay, so by using that corresponding alternate angles, that only we have to prove. So now given that AB is parallel to CD, so BC is parallel to D. Now whenever AB is parallel to CD, we have here AB is parallel to CD, we have here 3x is equal to 105. So why 3x and 105 equal? Those are alternate interior angles. Okay, here BC is taken as transversal and AB is parallel to the CD. So that's why here 3x is equal to 105. Okay, otherwise you can extend like this also. For example, we extend like this and this. Okay, and this becomes a transversal line. So that's why here 3x and 105 are the alternate interior angles. So that's why by this we can say, 3x is equal to 105 alternate interior angles. So then x is equal to 105 by 3, then x is equal to 35. 3 1s are 3 3s are 9, balance 15, so 3 5s are 15. So we get x is equal to 35 degrees. Now also here BC is parallel to DE. Okay, yeah, here we have to already BC is extended like this. So here DE is also you can extend in this way. Okay, in this way, then both are look like a parallel lines. Then here CD becomes transversal. So now immediately you can write angle D is equal to angle 105 degrees, this angle and this one. So why? Because again alternate interior angles. So 105 and angle D. Yeah, these two are parallel and CD is a transversal. So that's why 105 is equal to angle D. So in triangle CDE, we have again three angles, angle D, angle 24, that is angle C, and angle E. So by angle sum property we can write 24 plus the angle D value 105 plus angle Y is equal to 180 degrees. So by 180 degrees. So by the simplification we can write 129 plus Y equal to 180, then Y is equal to 180 minus 129, that is equal to 51 degree. So like this we can get x and y values. Okay, here also we used alternate interior angles and angles and property. Okay, so see properly these figures and do practice. And one more important tool, in the given figure BE perpendicular to DA and CD is also perpendicular to DA. Okay, BE and CD both are perpendicular to this DA. So then prove that measure of angle 1 is equal to measure of angle 3. Okay, these should be equal. So how can we prove? So here given that CD is parallel to DA and BE is parallel to DA, the two lines CD and DA are perpendicular to the same line DA. So by that we can say CD is parallel to BE. Okay, if two lines are perpendicular to the same line, then the two lines becomes what? Parallel to each other. So by that way we can say, or here angle D is equal to angle E, then CD is equal to B. Angle D is equal to angle E. How can we say? Here angle D 90 degrees, angle E is also 90 degrees. Whenever these two are equal, then we can say these two lines. Why? Because here DE becomes a transversal and CD is parallel to BE. Then we can say then angle D is equal to angle E equal. Then we can say CD is parallel to D. By the way, by which way we can say? So these two are like a corresponding. So corresponding angles for CD and BE and DA is a transversal. Here angle D and angle E taken as a corresponding angles. Okay, one is interior and other is exterior. So by that, by these two are on the same side of transversal DE. So that's why here CD and B are parallel. So in this way also we can say, okay, two ways. One is already, this is a basical, if two lines are perpendicular to the same line, then the two lines are said to be parallel. Otherwise, by saying here the angles, angle D and angle E are equal, and these two lines are intersected by transversal DE. So that's why these two are corresponding angles. These two are corresponding angles. Whenever corresponding angles are equal, we can say CD is parallel to PE. Okay, is it clear? Yes, you can. Now, by seeing this, we can say easily measure of angle 1 equal to measure of angle 3. Why? Here by observing CD is parallel to BE. Here DB is taken as a transversal. Then we can write angle 1 is equal to angle 3. That is measure of angle 1 equal to measure of angle 3. Okay, children. So total geometry is only observation of the figures. Okay, if you observe clearly, actually the targeted conditions whatever we are using, so that targeted conditions if you observe, then you can easily understand these type of sums. You can easily solve within seconds. Okay, now hence problem. Now one more interesting sum here, very important. Find the values of x and y for which ED and BC become parallel. Okay, already become parallel means already given these two are parallel. To make them parallel, so we have to, for which values we have to make them these two lines are parallel. So let us see. For the lines AD and BC to be parallel, x minus y must be equal to 30 degrees. Clearly observe the figure once again here. Here AD is the line and the BC is the line, and AC is taken as a transversal. Okay, so here the 30 degree and x minus y, these positions are same. So that's why here these two are corresponding angles. Okay, so one is exterior angle, one is interior angles, and both are on the same side of a transversal with the corresponding angles. Definition, we can say these two are corresponding angles. And moreover, already we have to prove AD, we have to find such a values for which AD and BC are parallel. That means AD and BC are parallel is already given. That's why x minus y is equal to 30 degrees we have to use. Okay, now 2x is equal to 8y. Again children, here AD is parallel to BC and AB taken as a transversal. That's why here 2x and 8y alternate interior angles, so we can equate it. 2x is equal to 8y. Now by solving 1 and 2 we can get easily x and y. So first of all, so multiply this first equation by 2. 2x minus 2y is equal to 2 into 30 is 60. Okay, so multiply first equation by 2, then we get 2x minus 2y is equal to 60. And take this 8y in the second equation, take this 8y to left side, we get 2x minus 8y is equal to 0. Now solve these equations by subtracting. By subtracting, here 2x becomes minus 2x, minus 8y becomes plus 8y. As we know, whenever we just subtract the given equations or a given polynomial equations, then here we have to change the signs of the second expression or second equation. So here we have changed minus, here plus becomes minus, minus becomes plus. Then on simplification, we get simply plus 8y minus 2y is equal to 6y is equal to 60. Generally this method known as elimination method. Here we eliminate one variable x, then we can get easily the other variable. So y is equal to 60 by 6, 6 ones are 6 10s, then y is equal to 10. So y is equal to 10 degree. Okay, now by substitute y is equal to 10 degree in the equation 1, then we get x minus 10 is equal to 30, then x is equal to 30 plus 10, 40 degree. Okay, very important sum here. So to practice well. So x is equal to 40 and y is equal to 10. Now let us see one more important sum here. So see this children, here actually we have a figure, find the values of x and y. From this figure we need to find x and y here a triangle is given like this, and here we have 30 degree y degree are interior angles, and one angle 140 degrees outside of the triangle. So by doing this, we can write from the figure y plus 140 is equal to 180 at this. So here these two angles are in the same line, so we can write simply y plus 140 equal to 180 in a pair of angles. Okay, now y is equal to, we can write 180 minus 140 simply 40 degrees. And again here this is a triangle and x degree is taken as exterior angle, then we know that exterior angle is equal to sum of the opposite interior angles, so x degree is equal to 30 plus y, but here y is nothing but 40 degrees, so 30 plus 40 equal to 70 degrees. So here we used linear pair angle definition and this exterior angle condition. Okay, very simple. Now see this one, very interesting one. In the given figure, segments shown by arrows, okay, arrowheads are parallel, okay, and find the values of x and y. Yes, it is. The single-headed arrow line segments are parallel, and also we have to find x and y. So from figure we can easily write x degree is equal to 30 degree. Why? Those two are alternate angles. Here the single arrowheaded lines are parallel, and this line is taken as transversal, so that's why x degree is equal to 30 degree. Those two are alternate interior angles. Okay, now here again y degree is simply exterior to this triangle, exterior angle of this triangle. So that's why y degree is equal to, we can write 45 plus x. Now substitute x degree. So here we can again have to write the reason. Exterior angle of a triangle is equal to sum of opposite interior angles. So that's why we can write y degree is equal to x plus 45. Then substitute 30 degrees in this x, we can get y is equal to 45 plus 30, that is 75 degrees. Okay children. Now PQR produce 2 points S and T respectively. Then find RPQ and PQR and PRQ. So we have to find the interior angles of this triangle. So given that angle SPR is 135 and angle PQT is 110 degrees. So from the figure, angle SPR plus angle RPQ is equal to 180 degrees. So here we have, and here we have the linear pair. So that's why SPR plus angle SPR plus angle RPQ is 180. Then angle PQT plus angle PQR is equal to is also 180. That is, both are linear pair of angles at here and here, at Q and at P. Okay. Now from the first one, the first relation, we can write our angle RPQ is equal to 180 minus angle SPR, and then angle RPQ is equal to 180 minus 135, that is 45 degree. And again here angle PQR at this position, 180 minus angle PQT, that is 110 degree, that is 180 minus 110 is equal to 70 degree. Now in triangle PQR, we have here angle sum property, RPQ, this angle, plus PQR, second angle at this Q, plus angle PRQ, third angle at R, is equal to 180. Now substitute RPQ 45 and PQR 70 degrees. Then we can easily find out angle PRQ. 45 plus 70, 115. And then angle PRQ is equal to 180 minus 115, that is equal to 65 degrees. So like that we can find. Now in the next sum, very important, in the given figure, angle X is equal to 62 degree, angle XYZ is equal to 54 degree. These two are given in triangle XYZ. We have angle X 62 degree, angle Y is 54 degree. In triangle XYZ, if YO and ZO are the bisectors of angle XYZ and angle XZY, that is at Y at Z, we have here YO and OZ are the angular bisectors respectively. Then we have to find the angle made by the both the bisectors. ZO are the bisectors of angle XYZ and angle XYZ expected. Find the angles of OZY, this angle, and YOZ and this angle. Okay. Now Switzerland given that angle X 62, angle Y 54, and YO and ZO are the bisectors of angle Y and angle Z respectively. Now in triangle XYZ, by angle sum property, we can write angle X plus angle XYZ plus angle XZY is 180 degrees. Then we can get 62 plus 54 plus angle XZY is equal to 180 degrees. Then XZY is equal to 180 minus 62 plus 54, 116. Then 180 minus 116 is equal to 64 degree. Now in triangle OYZ, again here OYZ, angle OYZ is half of the angle XYZ. Why? Because here YO is angle bisector. So half of angle XYZ, that is half of 54, that is equal to 27, since YO is the bisector of angle XYZ. Okay, and then triangle OZY, this angle is also half of the that angle XZY. How much it is? 64. That is half of the 64. Then we get 32. Then since the OZ is the bisector of angle XZY, so we got here two angles, this angle and this angle. Now angle OYZ plus angle OZY plus angle YOZ, so is equal to 180 by angle sum property in triangle YOZ. So therefore YOZ minus 59 is equal to 121. Why? Because here we got 27 plus 32, at these places we get 59, then subtract that 59 from 180, then we get 180 minus 59 is equal to 121 degrees. So like this we can find the angles. Now in the given figure, if AB is parallel to DA and angle BAC is equal to 35 degree and angle CD is equal to 53 degree, find angle DC. Now when given that AB is parallel to DE, angle BAC 35, angle CDE 53. If AB is parallel to DE, angle BAC 35, and now angle E is equal to 35 degrees, alternate angles. Here already is given AB is parallel to DE, then definitely here A is act as a transversal, then angle E is simply we can take this one is exactly a what alternate integral angle. So that's why angle E is simply we get what 35 degree. So then we got angle E as 35 degrees by alternate integral angles. Now in triangle CDE we have again angle sum property, angle C plus angle D plus angle E is equal to 180 degrees. So angle C plus 53 plus 35 is 180 degrees. Then angle C plus 88 equal to 180 degrees. Then angle C equal to 180 minus 88, that is 92 degree. Like that we can find that. Now here one more important one. In the given figure, ABC is a triangle in which angle B 50 degree, angle C 70 degree, sides AB and AC are produced if Z is the measure of the angle between the bisectors of the exterior angles. So find then find the Z. Okay, here BO and CO are the exterior angle bisectors of the exterior angles of triangle ABC. Then we have to find the angle made by them. So that is Z angle. Now see this once again the figure. In given that angle B is 50 degrees, angle C is 70 degrees, angle between the bisectors of the angles B and angle C, exterior angles B and angle C is Z. Okay, the angle formed by the exterior angles of bisectors of the exterior angles B and C is what? Z degree. Then from figure we can write 50 plus 2x. Why? Because here already has taken one angle is x degree, here BO is the angle bisector, then here x degree plus x degree, 2x plus 50 is equal to 180. Again here linear pair angle 2x and 50. So in similar way 70 plus y plus y, that is 70 plus 2y is also 180, which is linear pair of angles. Now from this 2x is equal to 180 minus 50, that is 130 degrees. 2x is equal to 130, x is equal to 130 by 2, then x is equal to 65. In similar way 2y is equal to 180 minus 70, then 2y is equal to 110, then y is equal to 1 by 2 into 110, that is 110 by 2, then we get 55. Visible. Now in triangle BOC, angle x plus angle y plus angle z, again the angles in property. Then 65 plus 55 plus z is equal to 180, then we get 65 plus 55 120, then z is equal to 180 minus 120, that is 60 degrees. So by that way we can find the angle z. Very important to practice well. Now see this, in given figure PQ is perpendicular to PS, PQ is parallel to SR, and SQR is 28 and QRT is 65. Okay, here we have the PQ is perpendicular to PS, this is the angle within these two 90 degrees, and PQ is parallel to the SR. PQ is parallel to the SR. Okay. Next angle SQR, is given as 28 degrees. Then angle PQRT is given as 65 degrees. Then find the values of x and y. Okay. Now here given PQ is perpendicular to TS, that is 90 degrees. PQ is parallel to SQR is 28 degrees, and angle QRT 65. Now from the figure we can write a QSR is equal to x degree. QSR is equal to x degree. Why? Because these two angles are what? Alternate entire angles. Okay. Why? Because PQ and SR are parallel, and here SQ is taken as transverse, then these two are equal. Now again by exterior angle property, here 65 degrees exterior angle to this triangle QSR. Therefore 65 is equal to, we can write x plus 28, and then x is equal to 65 minus 28, and that is equal to 37. Then we get x value as 37. Now and x plus y is equal to 90 degrees from the triangle PQR. Why? Because this is a right angle triangle. Already as given PS is perpendicular to PQ, and then here we got x value 37 plus y equal to 90 degrees. Then y is equal to 90 minus 37, then we get 53. So like this we can find. Now one more important sum. In the given figure it is given that AB is equal to AC, and angle BAC 30 degrees, angle ADB 45, angle AEC 40 degrees. Then find ABC, this angle, ACB, this one, DAB, this angle, and angle AAC, this one. Okay. So respect of these three angles, meaning all we have to find. Now let us see once again the figure. The first one, simply we can get ABC and ACB angles at a time. See this, given that AB is equal to AC and angle BAC 30 degrees, ADB 45, AEC 40, already as given. But especially in triangle ABC, AB is equal to AC. Whenever two sides are equal, then their opposite angles are equal. Now by using angles and property in this, we can get angle BAC plus angle ABC plus angle ACB, that is these three angles, sum of these three angles is 180. Then here ABC equal to ACB, that's why we can write ABC plus ABC, 2 times of ABC. Already BAC we have 36 plus 2 times of angle ABC is equal to 180. Then angle ABC is equal to 180 minus 36 divided by 2. 180 minus 36, 144, 144 by 2, 72. So angle ABC is 72. In similar way angle ACB is also 72. At a time we got these two values. Now further we need to get these two values. Again I am giving the same question, but here we need to find third and fourth. So first let us see third value. From figure, angle ABD plus angle ABC is 180 degrees. ABD and ABC at here. Okay, so is 180 degrees, but we have already that angle ABC value is 72 degrees. So ABD is equal to 180 minus 100, that is 108. By linear pair only, by linear pair. So we got here 72 degrees ABD. Now in triangle ABD, again go through this angles property at this triangle. So angle DAB plus angle ABD plus angle D is equal to 180. So angle DAB plus angle ABD 108, we have angle D 45 already given, so is equal to 180. So not 8 plus 45, 153. So angle DAB, particularly this value is angle DAB is equal to 180 minus 153, that is simply 27 degrees. So the third value is over. Now fourth one. Again I am giving the same figure. Yes, see in triangle ADE, we have angle D plus angle A plus angle E 180. So angle 45 plus angle A plus 40 is equal to 180 degrees total. Okay, he has taken full triangle which is like a outside of this triangle ABC, this triangle ADE. So angle A plus angle D plus angle E, otherwise angle D plus angle A plus angle E, anyhow it is 180 degrees. So here angle D 45, angle E 40. So 45 plus angle A plus 40 is equal to 180. Then angle A plus 85 degrees 180. Then angle A is equal to 180 minus 85, that is 95. But angle A is equal to angle DAB plus 36 plus angle AC at this portion. Okay, we have here actually 3 angles. So at angle A it is having 3 angles. So DAB plus this angle plus 36 plus and this angle, that is EAC. So angle A we have anyhow 95, angle DAB 27 plus 36, angle EAC. So 27 plus 36, 63. Take this 63 on left side, we get angle EAC equal to 95 minus 63, that is 32. So this sum is very very important. Practice well. Now one more important sum here. Here from figure we have in triangle ACB 34 plus 62 plus angle ACB is 180 degrees. Okay, this triangle ACB, again we are applying the what angle sum property. 34 plus 62 plus angle ACB is equal to 180. Then by the angle sum property, then we get angle ACB equal to 34 plus 60, 96, 86, 96 on right side. Then we get 180 minus 96 is equal to 84. Then next, and x plus ACB, linear pair again here. Let us see, we have the linear pair. So x plus 84 equal to 180, then x is equal to 180 minus 84, that is 96. We got this value as 96. Next, or x plus 84 is equal to 180, then 180 minus 84 is equal to 96. Okay, now or also we can find here x is the exterior angle of triangle ABC, then 34 plus 62, simply we get 96. 60 is the exterior angle of triangle ACB. So in these ways we can find out that x values. Now for y value, again here to get y values, observe this DCE triangle, observe this triangle. So here y is the exterior angle of this triangle CDE, so that's why we can write y degree is equal to 24 plus x. Okay, exterior angle of DCE, so that's why y degree is equal to 24 plus x. Exterior angle is equal to sum of its opposite interior angles. So that's why 24 plus x, but we have our x degree is 96. So 24 plus 96 equal to 120. So like this we can get y value. So very very important, do practice. That's enough. We will